So this video is about assembling the analog navigation keypad kit. We will start with reviewing the tools that you will be required to use during the assembly. Amp voltmeter, soldering iron with some flux and rosin core. I will use cutters, and that's pretty much it. Something I forgot to mention, but I found extremely useful, is magnifying glass. The kit comes with PCB, some switches, the joystick, the headers, resistors. I'll start with inspecting the PCB. The PCB is extremely simple, so I have never encountered any problems with PCB, but just in case. The first thing that I do is to figure out how to mount this joystick. I admit I still don't know the orientation of this one. So here's the trick that I use. I dry mount the joystick, and then I measure. What I do know is that this pin, bottom right, is ground, and this pin, bottom top right, is the center. So I measure the resistance between those. It's infinite, and when I press, nothing happens. I think this is because I mounted the joystick in the wrong way, so I take it out. I mount it like this. I rotated the joystick and mount it again. And I will repeat the exercise, check the resistance between this point and this point. It's infinite now. Okay, let's do it again. Resistance between this point and this point. Zero. Infinite. Zero. Infinite. Okay, so I found the orientation of the joystick, the correct orientation of the joystick. The switches, no mystery here. Only one way to mount those, no matter how. It will always work. Okay. Number one switch, another switch. I forgot to mention, so the orientation of the text corresponds to the correct orientation of the board. Okay, so we're done with the switches. The only thing left is to install the headers and the resistors. This header is, I used it for debugging purposes when I needed to connect my amp meter to the ground. There is really no need to install anything here. Both of those are connected to the ground, and I would just solder a small wire loop so that I can connect my alligator clip of my amp meter. So really no need to use this. I will proceed now to figuring out which of these resistors goes where. And for that I will need my schematics right here. You may not see it, but there's no need to see anything. I don't remember the markings of those, so I will just measure the resistance of every one of those. and install it in the PCB in the corresponding location. So this one is 3.6K. 3.6K is R1. I should actually mark the values of the resistors as opposed to the names. So it's up to you where you want to mount those. I prefer for the top to be kind of clean and to have the components mounted on the bottom side, and then I have headers like this, as you will see. But it's totally up to you. There is nothing that would prevent you from mounting resistors on this side. Okay, 2 more to go. It's okay if the value is 10% or so. The software should account for it. Okay, so all the components are mounted. We can start soldering. Okay, and we are done with soldering. Now I cut the leads. Okay, good. Now you may or may not want to solder in the headers. It depends on your intended usage of this board. I do prefer to have those installed. Straight enough. Let's solder it. Okay, one header done, one to go. So the board is assembled. Let's have it cleaned and tested with example software. In the PCBs I use denatured alcohol and the brush. And that's pretty much it. Let's have it dried. Okay, now we're ready to run our test software and verify that the board works as expected. Okay, now that we assembled the analog navigation keypad, let's test it. I put it here on the breadboard along with Arduino Nano. Connection are done using jumper cables, 4 of those, ground, VCC, and 2 analog lines. The test sketch along with the library file is available from GitHub. Here, let's have a look at the test sketch. It's including the header file. I derived my own My Navigation Keypad class from the library class in order to override the callbacks on user inactivity, on key auto repeat, on key down, on long key down, on key up. Here in this callbacks I didn't do anything useful except print debugging information. Another important thing not to be missed is that I specify the pins to which the keypad is connected. A1 and A2, could be A0, A1, any 2 analog pins will do it. I don't do anything dramatic in the setup function. And in the loop, I just call a single function, get and dispatch. Let's upload the sketch. Done. And let's have a look at the serial monitor. So when I press my soft B button, down and up, I just get on key down, on key up. Let's do the same with soft button A. It works. On key down, on key up. Let's button B, let's do long press. Press, hold, I get on key out to repeat, and then on long key down, and then release. And the same can be done with button A, as well as joysticks. Let's have a look at what happens when I press two buttons. So, by the way, before we proceed, let's have a look at the fact that when I'm not using anything, my callback on user inactivity is being called. So, I press button B, and then I press button A. And note that on my on key out repeat now has information about both buttons being pressed. The whole point of making this keyboard was to make sure that I can press not only left and up buttons, but also that I can press those simultaneously. Let's test it. I want to press button left and then press up. And you can see that right now both up and left are pressed. On key up I got for both buttons. On key down, on key up. Up, on key, okay, yeah. So right now you can see I can press both buttons simultaneously. Left and left down. Down, left, now both of them together. Alright, that pretty much concludes the testing of analog navigation keypad. Thank you for your time.